All right, we're looking at conditional probabilities today. Conditional probabilities. This is what a conditional probability looks like as far as the algorithm that we proceed with. This right here is probability that A given B. The probability of A given B. Or the probability that A happens with the condition that B has already happened. Okay? And that's going to be this, the probability of A and B both happening divided by the probability of B happening. Or it could be reversed. Probability of B given A, probability of A and B happening divided by the probability of A happening. The thing about this is every time on the bottom, the second one is on the bottom, what you're dividing by. Now, what does this mean? It means something like this right here. Here's an example that might help some. What's the probability that it rains given that it's sunny outside? Okay, now if you think about it, how often does it rain when it's sunny outside? Not very often. So that's a very, very small probability. But here's the thing. If I write this out, the probability that it rains given that it's sunny outside, I'll just put R and S for rains and sunny. Okay, so this is going to be the probability that it rains and it's sunny outside divided by the probability that it's sunny outside. See, this second one here is always on the bottom. So this is what this one would look like. Okay, which means this, the percents that it rains and is sunny is not very much. And so given that it's not sunny outside, well then if it's not sunny outside, that's going to make this probability go down even more because it's not sunny, so it's not raining and being sunny. I don't know if that makes sense or not. But given that it's sunny outside, that makes this probability more, makes it a little bit higher because it is sunny. So the condition of it being sunny is already in place. Yeah, I don't know if that makes sense to you guys or not. Here, I'll just go this first problem, okay? And maybe this might make sense here as we do it this way. The following table indicates the pets that have been looked at this month at the animal hospital. So you can see there's male and female and dogs and cats, and here's the totals out here on the sides. All right, if a pet is selected at random, find the probability that the pet is male. All right, so here we're just finding the probability that we have a male pet. Okay, so if you look at the male, here's the males right here. All right, the total males is 52, and the total altogether is 100. So here the probability that it's male would be 52 out of 100 total. And so I just divide that, that just be 0.52. Now I think it says round 3 places on the problem, so we just put a 0 on there, so that would be the probability. So these are just simple probabilities right here. We'll look at the conditional probabilities in just a minute. On this one right here, if a pet is selected at random, find the probability that the pet is female. It's the same thing here. So on this one, probably it's female. So here's females right here. So total is 48 out of 100 total. So this is going to be 0.48. Okay. What about this one here? Find the probability that the pet is a dog. Find the probability. So on this one, the probability that it's a dog. Okay. So we look at dogs. Or here's dogs right here, and the total dogs are 51 total out of 100 total. So this is going to be 0.51. I'll add a 0 on there to make 3 places as needed for the problem. Okay. All right. Now here's a conditional one. If a pet is selected at random, find the probability that the pet is a cat given that it's male. All right, so we want the probability that the pet is a cat given that it's male. This is what we're doing here. Probability that it's a cat given that it's male. Let me slide this over now. This is going to be probability that it's a cat and a male divided by the probability that it's male. Remember, this second one's always on the bottom. the top, we have both of these. It's going to be a cat and a male divided by the second one, which is male. So here's what I want to do. All right. So the probability that it's a cat and a male. Now, if I look at my thing here, all right, it's got to be a cat and it's got to be a male. All right, that's 10. Okay. So that means this top part is going to be 10 out of 100. Okay. Now the bottom probability that it's male, all right, the male, total males is 52 out of 100. So this is going to be 52 over 100. Okay. Now, let me just show you this. When you divide fractions, you keep, change, and flip. You keep this one on top, so that's going to be 10 over 100. You change from divide to multiply, and you flip the bottom one, which is going to be 100 over 52. And if you notice, these hundreds will cancel off. So really, the hundreds cancel off. It's just going to be 10 divided by 52. So if I just go back to this, it's just going to be 10 divided by 52 here. And so when I have this contingency table, I can just do 10 divided by 52. And so 10 divided by 52 is going to be, all right, let me see here. 10 divided by 52 is right there. 0, well, can you see it? 0.192. And that's the probability that the pet is a cat, given that it's a male. Okay. We'll go number 5 here, and I'll show you, well, I'll show you the expedited version of what I just was trying to show you here a minute ago. If the pet is selected at random, find the probability that the pet is a female, given that it's a cat. All right, so it's got to be probably that it's a female, given that it's a cat. So it's going to be female and cat, I didn't put my P in front, divided by probability that it's a cat. Okay, so probably that's a female and cat would just be that number right there, 39. Probably that's a cat, all right, cat, here's cat, and the total cat is 49. So that's 39 divided by 49. All right, so if I punch that in, 39, well, 39 divided by 49. Okay, there it is right there. It's 795. Now look here now, 795, but this 9 right here makes that 5 go up to 6, so 0.796. And that'd be my probability there. Okay, number 6. All right, same thing here. If pet's selected at random, find the probability that the pet is a dog, given that it's male. So we want the probability that's a dog, given that it's a male. That's what we're finding. All right, so it's going to be the probability that it's a dog and male divided by the probability that it's a male. So it's dog and male divided by male. All right, dog and male, if you go to the chart here, dog and male is right there, 42. Now, male, all right, male is right here, and total is 52. So that's 42 divided by 52. All right, 42 divided by 52. Right there's my answer. Okay, 807. But see the 6 here makes the 7 go up, so it's going to be 808. So 0.808. That would be my answer there. Okay, here's another one. And we'll try to speed it up a little bit now. So find the probability that the pet is a cat, given that it's female. Probability that it's cat, given, female. So that's going to be probability that it's cat and female divided by probability that's female. So cat and female right there, 39. Probably it's female, here's female right here, and the total's 48. So this is 39 divided by 48. 39 divided by 48 is going to be, all right, so 812, the 5 makes the 2 go up to 3.813. Okay, number 8 here. I got several of these I want to do. Find the probability that it's a male given that it's a dog. So probability that's a male given that it's a dog. So this is probability of male and dog divided by probability it's a dog. So male and dog right there. And then there's probably, so it's 42 over 51. And you divide those. Okay, we're not going to divide them. All right, on this one, find the probability that the pet is a dog given it's a female. So probability that's a dog given female. So that's going to be probability a dog and female divided by the probability that's female. Okay, let me get it over here just a little bit. Dog and female on top, female on the bottom. All right, dog and female right there, there's 9, that's the top number. That's dog and female. And then probably it's a female right here, 48. 9 divided by 48. So you just divide those around in 3 places. All right, 10. Now you may have caught on already. We've got a different one here. This following table displays results from a survey of employees at a particular factory. So there's male and female, some smoke, some do not smoke. Okay. Find the probability that the employee is male. So that's just probably that he's male. So the male, there's 68 total males out of 121 total. And you just divide those. See the total right here. All right, what about this one? All right, and this is the same employees thing. Find the probability the employee is female. All right, so female right there, total, 53 total. And there's 121 total. Okay. So see the difference here on this, probably that it's female, the total female divided by the total. See on this one, it says find the probability that the employee smokes. All right, so smokes right there, there's 41 that smoke out of 121 total. Okay, now switching to this, here's some conditional ones. Okay, find the probability that the employee is male given that he does not smoke. So this is probably that he's male given does not smoke. I put NS. All right, so it's going to be the probability that he's male and is not a smoker divided by the probability that he's not a smoker. Okay. So probability that he's male and does not smoke. Male and does not smoke is 43 out of 121. But you know, the short way, you don't have to worry about that because they're going to cancel out, like we showed you a while ago. On the bottom, probably that he's not a smoker, or he's not a smoker, is 80 out of this, which is just 80. And then you divide those. Okay, here I'll divide those real quick. 43 divided by 80 comes out to 0.05, and I would add a 0 on it to have 3 places, if that's what it requires. All right, 14 here. If employee selected at random, find the probability that the employee is female given that the employee smokes. So probability is female given smoker. So that's going to be the probability that he's female and smokes divided by the probability that they smoke. All right, so female and smokes is right there, 16 out of 121. Divided by the probability he smokes is right there, 41 out of 121, which is just 41. Because when you do this keep, change, flip, they cancel and stuff. And you divide those. Here, I'll do it real quick. 16 divided by 41 comes out to be this right here. All right, so 390, and the 2 does not make the 0 go up, so 390. That'd be my answer right there. All right, 15 here. Find the probability the employee smokes given that is male. So probability that he smokes given he's male. So that's going to be probability he smokes and is male divided by probability that he's male. Okay, so he smokes and is male is right there. It's 25 out of 121. Divided by probability he's male. All right, male would be over here, 68. Divided by 121. The 121s would cancel and just be this. And you divide it. Okay. All right, find the probability the employee is female given that does not smoke. So probability female given does not smoke. Okay, that's going to be probability female and a not smoker divided by probability that not a smoker. So female and does not smoke is right there, 37. See, female does not smoke, 37 over 121. And then probably there's not a smoker. All right, not a smoker, down here, 80 over 121. And the 121s will cancel and just be this. And I divide that. Okay, 17. Find the probability that the employee is male given that the employee smokes. So probability that he's male given he smokes. Now we just did one a while ago. It was opposite of this. Probability he smokes given he's male. It was this. Right here, 25 over 68. I'm just going to write it on here. 25 over 68 is what the other one, what these are reversed. Okay? Now notice it's going to be different because here, so we're going to have employee and smokes, or male and smokes. This is going to be right on here, male and smokes divided by probability smokes. All right, male and smokes is 25. So see the top number is 25, just like that was. But here's the probability smokes, which is down here, 41. So see, it's different. This is not the answer there. Here's the answer for this one. And then last one on this bunch. All right, find the probability the employee smokes given they're female. So probability smokes given female. This is probability smokes and female divided by probability of being female. So smokes and female is 16. Right there, see there? 16 out of 121. Divided by probability that they're female. Female is right here, 53 out of 121. And the 121s will cancel. I just divide those. Let me divide that one. 16 divided by 53. And there you go, 301. But look here now, this 8 makes the 1 go up, so it'll be 0.302. Okay. Now we're going to shift gears here a little bit. Now here it gives the conditional probability layout right here. All right. Now, the probability that an airplane flight departs on time is this. Probability that a flight arrives on time is this. Probability that a flight departs and arrives on time is this. Or we want to find the probability that a flight departed on time given that it arrives on time. So probability that it departed on time given that it arrived on time. So that's what we're doing here. All right, so this is going to be probability of D and A divided by probability of A. Okay, so the probability that it departed on time and arrived on time, well, probably departs on time and arrives, it's 0.74, so that's the number on top. On the bottom, probability that it arrived on time, all right, probability that the flight arrives on time is right there, 0.78. And I just divide those. All right, so let's see here. Right there, 0.9487. Can you see it there? 0.9487. The 7 makes the 8 go up to 9, so it's 0.949. That'd be it. Okay. What about this one here? Find the probability that the flight arrives on time, given that it departed on time. So this is probability that it arrives on time, given that it departed on time.
Okay, which is backwards what we did up here. See, this is D and A, D given A. This is A given D.
But it's going to be the probability of A and D both happening divided by the probability that D happens.
Okay. And so I just read these and put them in the right spots here. So probably that arrived and departed on time, probably the flight departs and arrives on time would be this right here, 0.74. Probably that it departed on time, departing on time is right there, 0.79. All right, so I divide those. And I get this right here, 0.937. See here? This was 936, but this 7 makes this 6 go up to 7, so 937. And that's what that would be. So you can see the difference, a little bit difference in the two answers here. Okay. Well, we got two more. All right, so on this one, number 21, we've got this accompanying table shows the number of male and female students in a particular country who received bachelor's degree in business in a recent year. Okay. Find the probability that a randomly selected student is male given that the student received a business degree. So we want probability that they're male given that they got a business degree. So it's going to be probability of male and business degree divided by probability of business degree. So it's both of these on top, just this one on the bottom. All right, so looking at the table here, I may just write my answer over here so I won't have to move it any. Let's keep the table on the screen. I'm running out of room over here. So, but probably that they're male and have a business degree. Male and a business degree is this number right there. Probability that they have a business degree, all right, business degree is right there. And I divide those. All right, let me see here. 197,544 divided by 364,441. And there's like that. All right. 542. This 0 does not make the 2 go up, so it's 542. Okay. Now this next part, scoot it up just a little bit. From the probability the randomly selected student receives a business degree given that the student's female. So that's probability that they get a business degree, but given that they're female. All right, so this is going to be probability that they're a business degree and female divided by probability that they're female. Okay, so looking at the table here, look for the number that has a business degree and female. Well, that's this number right here. I did much here. I'll do a different color this time. Right there. Okay, that's the number that goes on top. All right, probability that they're female. All right, female is right here. And I divide those. So if I divide them, 166,897 divide by 1044932, and I get this right here, 159. And look at the 7 makes the 9 go up, so it's going to be 160. Okay, and then one last one right here. The company table shows the results of a survey in which 250 male and 250 female workers aged 25 to 64 were asked if they contribute to a retirement savings plan at work. Do you contribute to a retirement savings plan? Okay. All right, so this one says find the probability that a randomly selected worker contributes to a retirement savings plan at work given that the worker is male. So they contribute. So this is probably that they contribute given that they're male. Okay, which is going to be probability that they contribute and they're male divided by the probability that they're male. All right, so they contribute and they're male would be this right here, 127. Probability that they're male is right there, 250.
So just divide those. All right. 127 divided by 250. All right, 0.508. Look it up. It's already 3 places. Okay, and the last one down here. Find the probability that the randomly selected worker is female given that the worker contributes to a retirement savings plan. So the probability that they're female given that they contribute. So it's going to be the probability that they're female and they contribute divided by the probability that they contribute. So the probability that they're female and contribute is this right here, 155. Female and contribute. Probability that they contribute is down there at the bottom, 282. So I divide those. 155 divided by 282 comes up to be this right here, 549. But if you look there's a 6, makes the 9 go up, so 549, 550. Oh, I didn't put my 0 point. And there you go. All right, so this is conditional probabilities. I hope that kind of helps you some. If you have any questions, just contact me and I'll try to help you all I can. So have a good rest of the day.